Getting started with the Arduino with the Blink script. So basically for this Blink script you're going to need your Arduino. I've got an Uno here. It's going to be using pin 13 and ground, so that's a digital pin. Then you've got an LED, a 330 ohm resistor and a breadboard, and then a couple of wires just to connect it up. So with breadboards they generally have tracks, so this one goes along like this, and then the same on the other side. That way you can put chips in. So we only need two. We want to make sure they're not on the same track since we don't want it to short circuit. With an LED, to tell the difference, one leg is slightly longer, so that's the positive. This one's the negative. And also if they're cut the same length, which sometimes you see, down the side this has a flat face for the negative. So when we plug this in there, we want to have one of the resistors. Why we use a resistor is to limit the current. An LED is a diode, so it has a small internal resistance. Because of this, we, in theory, it just can take a lot of current from the board, and that can burn out the LED. So this is to limit it. So the white's going to be the positive, and the blue is going to be the negative. So the positive will go on to pin 13, and negative will go to ground. And then on the script, what we're going to do is we go to File, and you'll see under Samples, there's a thing called Built-in Examples. This is Basics, and then we go to Blink. So I'll make this big. This script is provided by Arduino. It's quite a simple one. All it's saying is use a built-in LED, which should be linked to pin 13. And what we want to do is we want to set this pin to an output, which means we're going to be telling it what to do as opposed to letting digital come in. And then we want to loop through, and what we do is we turn the LED on. So we set it to high, the pin, so that'll be set to 1. Digital pins use zeros and ones, so we'll set it to 1, which means it's on. So that'll be having 5 volts go through. Then we delay for 1000 milliseconds, so that's a second. Then we want to turn it low, which means to set it to ground, and then finally wait another 1 second. So if I upload this, what you want to do is you go to Tools, Board, and you should see on Arduino boards, you'll see the Uno. It's got to match the same board you're using. Ports set to COM, so it's whichever one comes up. It should say in brackets, so that'll be correct. And once that's done, we click Upload. First it will compile, which means it's going through the script to make sure there's no errors and that it's going to run. And then secondly, it will upload. So as you can see, we've got both the LEDs turning on. We've got the built-in LED, which is just there, and we've got the red LED turning on there, but it's quite dim. I'll bring it a bit closer, hopefully you can see it. Now we can switch it. So if you go here and you don't want to use the built-in one, say you want to use a different pin, you can just type in the pin number. So we're going to use pin 13, exactly the same. And we can click Upload. And it will compile again, and it does this every time you upload. It's just to make sure there's no errors in your code. And it will upload, and it's still running. So let's change it to pin 12 for example. So this is not the built-in LED pin. We'll just set these all to 12. And when we upload this, you'll see it also goes through the compiling, uploads, but the LED won't be blinking. Now the reason for this is because this is connected to pin 13. So if we switch this over to pin 12, now it's blinking again. However, the LED one is not, the built-in LED will not be blinking. So it's quite a simple script. Now there's many different ways you can code this script. There should be other samples as well. So we go on to basics. You know, there's a fade. I believe this one also works. So yeah, this uses pin 9. And then how much it dims and the brightness settings. So pin 9, the reason they use that is because it's got PWM, which is pulse width modulation. With that, you're sending a frequency out of going on and off. So ones and zeros as a frequency, and because of this in a certain pattern, reduces how much electricity is getting through and makes the brightness change. So we're going to use the pin 9 with the built-in settings. Again, you want to make sure that the tools are set up correct, and it should be the same as the last one you used, so that's quite simple. Now it should have uploaded, and you'll see it slowly goes down and brightens up. So I bring that a bit closer. There you go. You can see it a bit better now. So yeah, there's different ways of doing this, and there's many different samples we can go through, and under digital there should be another one, blink without delay, so you can try this. So this uses a built-in LED, but we can set this to any pin we want. The reason they've done it like this is to, instead of constantly writing the pin number down, you can set the pin to a variable. So if we say a constant integer of LED pin, and we set this to pin 13, or the built-in one, it's both the same, and then we start with a state. We set this to low, and then they're going to set a timer up. So the reason we're setting up a timer in the interval is because this one's going to loop through and check if the time is greater than. Instead of doing a delay, it will constantly loop through and does this constant check. So we set the LED to an output again, quite simple. And we set the current millis, so this is what's the current time, how many milliseconds is currently started, set it to start. If it's less than the previous, so the previous should be 0, so no, if it's minus the previous, it's more than the interval. It's basically saying if the time that's lapsed is more than 1,000 milliseconds, then what we want to do is set the previous one to the current, and then we want to check the LED. If it's low, we set it to high, and if it's high, we set it to low. You don't need to say if twice, because if this is false, then this one will run. So if LED state is low, so off, set it to high. Else, if this is false, so this means LED would be high, that's the opposite, then we set the LED to low. And then what we do is we write that to the pin and say what state, so it'll be low or high. So let's upload that, and we'll change this over to pin 13. So it's going to compile, and then it will upload, and then we got it back again. So this is working slightly differently to the first blink script I showed you. So the first one uses delay, and this one is constantly just checking and just uses a timer. So I hope you find that tutorial quite simple to follow through. If you get stuck, message me on my Instagram. You'll find that in the link below. Don't forget to like and subscribe, and I hope to see you guys soon for more tutorials.